All right, we are ready to begin. So here's the quiz. Does anyone have any questions or things that they wondered about over the homework?
I'm still trying to understand.
Still trying to understand.
I understand, but when I get confused when, like, which number goes where in the formula. Sometimes I get confused, and I need to go over it again and again, but
I know I got confused on number 6. I put it opposite. I subtracted the wrong thing from the wrong things, but yeah. I need to pay closer attention, I think.
and then when we use the what's the word? The percentiles, I don't understand what is the part that we have to shade in the applet. I get lost in that too.
Okay, yeah, it's all a matter of wording, and it might even be just a language barrier, just because, you know, even though you speak perfect English, there's still just the wording is a little tricky sometimes.
Yeah. Well, question 3 is a perfect example because it asks about the shading. So should we start there?
Sorry, number 3. Is that where we?
Yeah.
Okay. Yes. Go ahead.
Yeah.
You want to start,
Yeah. It says use the normal probability applet to find the combined area under the standard normal curve that is to the right of the z-score 1.3858 and to the left of negative 1.358.
Okay.
So first you'll need to go to the applet and put in the 1.358 since we're just doing with negative and positive. And then again, it wants to the right of the positive and left of the negative. So should we just highlight those two on the outside?
Let me see.
Are you following this, Monica?
I'm doing it.
Okay. We want to make sure you understand this because this is about the shading. So.
Okay, so we only shade the sides.
Yeah. You're right. So to the right of the negative, or to the right of the positive and the left of the negative.
And using 1.358.
1.358, you got it. So what's the area, it's the number at the top that you have?
So it's 0.1745?
Correct.
Yeah, and then you round it to the third.
Right around the third, so it's 0.175.
Okay.
Should be the answer.
All right, I'll take the next one. It says, which of the following will have a small standard deviation? If 9 observations are randomly drawn from a population. Let's see, the distribution of the individual observations, or the distribution of the sample means, or this information cannot be determined from the information given. I remember one of these on the first quiz, and I got one of them right and one of them wrong. So I think I put, for one of them, this can't be determined, and it was right. But the other one, when I said that, it was wrong.
So, well, I think it's the distribution of the sample means, because when you're going with sample means, that means we're going to have to divide it by 9, because that's the sample. And so that would make the number smaller rather than dividing by like 1 if we just do an individual operation.
All right, I'm
Does that make
gonna
sense?
look at one of the equations just to see.
No, that's a great idea.
What's just so I can understand it. Let's see. So if you take the individual observations, what's the distribution? What does it mean, the first one? Is that just the population? Is that what it's talking about? Distribution of individual observations?
9. So essentially, here's an example of what we're doing. So let's say I have these samples, right? And I randomly pick a 10. And my mean is 8. So that means I would have the number 2 at the top. But then in order to get the standard deviation, I need to divide by the population, right? I need to divide by the standard deviation that I have and then the square root of the population. So in that case, the square root of the population will be 1 because I only picked one value, is how I'm understanding it. Is everyone following me? Or am I totally lost?
I'm lost.
Yeah, I'm lost.
I don't get it.
Okay, it's talking about 9 being drawn randomly from
9?
a population.
Okay.
So if 9 are drawn and our original number is, you know, it's 10 minus 2. So if z equals 10 minus 2, so that would be 2 on top. And then the standard deviation is, it could be anything, but it has to be divided by the square root of 9. That makes it a smaller number.
You got it.
Divided it by 3. So, which of the following will have a smaller standard deviation? And so that makes sense to me that if you divide it by the, if there's a sample mean. No, if you have a certain number, that's what makes it. So I don't get it. I don't understand the difference between individual observations or sample means.
Yeah, me either.
9 observations were randomly drawn from the population.
I'm gonna check the book.
I mean, the 9 is what would be giving us a smaller number. If 9 observations are drawn.
Then yeah, because if there's 9 different numbers, then we don't know what the numerator is. So I'm thinking it is that we can't determine it from this information given.
Okay, let me just look at the other homework assignment that I was confused on, but then it tells you the answer. So let me just see. Here we go. It was the one earlier in the week.
Okay.
It was, okay, there was number 13, and then there was, might have to do with number 13 on lesson 6. Equal to or less than the parent population standard deviation. No. It's
gonna
small.
check
Okay, number 13, it said, is the standard deviation of the distribution of the means greater than, equal to, or less than the parent population standard deviation? And this homework says, or this quiz says, which is a smaller standard deviation if 9 are drawn. Is it the sample mean?
Don't we need more data to determine that? Like just
That's
with
what I'm
one,
thinking.
yeah,
I mean,
with
we
one
still need
number?
more data. Because again, if we chose an individual random number, it could be a very large number and our numerator is very large.
Yeah, 'cause
That's
I'm not that I don't know how to do it with just one number. I think we need more things.
okay.
Okay, well, that's what I would put for now, but,
Okay, so as of right now, I'll go with this cannot be determined, and then I'll submit the quiz first and see if that's correct or not, okay?
well,
There's no reason for all of us to get it wrong, so I'll submit it first at the end, and we'll
you
we'll
get
see
2
what that
chances, there's a 1 chance thing.
No, this is, all quizzes, you get 2 chances.
Yeah, 2 chances.
Okay. All right, number 5. Charity, you want to do number 5?
Yeah, sure. Which of the following results implies that the spread in X bar decreases as the sample size increases?
The spread in
Hold on.
sample size.
So I remember in that other thing that when it talked about spread, the spread had to do with the law of large numbers.
Large, yeah, I think so. And this
Yeah, because the
question-
larger the number gets, the closer that it's going to get to the population mean.
Okay.
And I can't remember where it said that either. But
in
I
the,
remember,
I think it was in the lesson from Tuesday.
yeah, it was lesson 6.
why is this quiz on lesson 6? Come on.
That's
I
why. I don't know. That's why.
Well, the first, we always do the first couple questions
like
on 6.
Tuesday
and
that I
then
read it.
7.
Okay, so now my turn. Use the following information to answer the next 4 questions. Scores on the quantitative portion of the GRE are approximately normally distributed with a mean 150.8 and the standard deviation of 8.8.
It's a calculator one.
Diane earned a score of 160 on the quantitative portion of the GRE. What is the C-score corresponding to Diane's score? Round the answer to 3 decimal places. Okay.
And again, this has to do with kind of what we learned on, not like last week, right? We're not going with the square root of the population because this is just the 1.
This was in the
Good.
lesson today. It was similar.
Yeah, because they're kind of reviewing, which is nice that they're reviewing it for us from last week.
So this is the one where you do the value minus the mean divided by the standard deviation.
You got it. So I
Divided
have,
by this size square root thing.
We don't have to do divided by the square root thing in this case because we don't have a sample population. This is going back to like chapter 5. So I have, yeah, so it should just be the 160 minus the 150.8 divided by the 8.8 of the standard deviation. So I have 1.045 is the answer that I got. And let me know if anyone. Okay.
I'm gonna tell you. I'm working on that.
That's what I got too.
Why are you
So
reading
it's
all?
1.045?
Correct.
All right, Kaylin, you want to do 7?
Yes. What is the probability that a randomly selected student score above 160 in the quantitative portion of the GRE?
Oh, okay.
So we
All
have
right,
to use
so we
that.
gotta- Yeah, so again, we have that. So now we got to switch over to the applet and put the z-score in that we got, 1.045. And they want to know, hey, okay, hang on.
Above.
That's right.
We'll score above. So we just want to the right of it. So I have 0.148.
That's what I
Yeah.
got.
0.1. Yeah, I got the same.
Okay, the next one says, a random sample of 5 students was selected. These are their scores. What's the z-score corresponding to the sample mean of the students' scores? Okay,
So this is the new formula.
we don't care what their score is, do we?
You have to find the mean of them. So you have to add them and divide.
Don't you want to take the mean of the previous? Oh, but corresponding to the sample mean? I mean, don't you keep the mean of the?
Go to your bed. Go.
Yeah, I think we need mean.
Are we using the mean from the
Well, we
It's
can.
first?
Oh,
Where's
did it- hold on. We got to go back to the original data. Is the original data normally distributed or not?
It is normally distributed.
It is normally distributed. So we're okay using the 150.8.
Yep, 150.8.
Okay. So this is the new formula.
Very good.
So we don't have to use the sample that they are giving us?
No, because it already gave us the mean above.
And it's always the same? Yeah, because it's normal. Yeah. Am I right?
This is
Yeah.
z-score.
So because they're both normal, we know that it's the same data. So we can use the one above, mean above.
That is 160? No.
Wait, what are we subtracting it from though?
Yeah, so
That's
we
what I
need to
was-
find, we actually do need to find out the mean of all these scores.
Oh, so we do that first and then we'll subtract it. That
Wait,
makes sense.
so the mean above isn't the mean
We,
for
No,
well,
that is, that's the regular mean. Oh,
150.8. Is that the mean?
well, it comes out to 160, Annie. It comes out to 160, guys.
Yeah,
Because
160.
if I add 160
Yeah, I got one.
plus 175, you got 162, so it's 160 anyway. That's
yeah, I see
annoying.
that. Okay, so we take 160 minus the 150.8, right? Minus
Yeah.
150.8 equals.
But
and then
this time, we have to do the sample of 5.
Yeah.
So this time we have to take that 8.8 divided by the square root of 5.
Wait, where did you get the one? Oh, for the 160, did you just add them and divide? Is that what you mean?
You got it. Yeah, we just took the mean of them.
divided by square root of.
I hate square roots. I feel like I get endless amounts of decimals and I never know where I should round to get the right answer that they're getting. But
Okay, so I got an answer, but let me just write down and see if, hold on just a second. I have such an old fashioned calculator. Hopefully I'm doing all the parentheses and everything right. I got 2.338. Tell me what you guys got. What
I
you
have 2.338 as well.
got. Okay.
If you guys need help with that equation, let us know. Go ahead and work through it though.
Okay. Yeah, hold on. I'm still putting it in my calculator. I'm trying to make sure I'm doing this right.
I'm sorry, just give me a minute. I just have to sign some papers.
No, you're fine.
Okay, what did you guys get?
2.338.
Okay, good. That's what I got.
All right, and number 9, it looks like we're putting the probability applet.
So the answer is 2.338?
Yeah.
Yes.
Mhm.
Okay, sorry. Okay. Are we number 9?
Yeah.
Yeah, I think Charity's up.
Okay.
Okay.
What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem?
I don't get that.
Oh, I think we have to
So-
take. I think we have to take the 2 z-scores. We got to take that 1.045 that we got with that first one, and look at the other z-score, the 2.338.
And
They
then
want to
shade the
know and shade the one
Greater?
area. I think is it greater or is it would it be in the middle then?
What's the probability that 5 random students will have a mean score that is greater than the mean achieved by students in the previous problem? Why do you need 2 different ones? Don't just take the one from,
Yeah, just do the 2.338 one.
yeah, and then do what's above it.
So I don't get it. What do we have to? That I get lost in this. I don't.
So it's asking about the problem before it. So we go back to question 8 and get the z-score for that, which is 2.338. It's what we just figured out. And
Mhm.
we're going to put that into the applet for the z-score and shade to the right of it because it's asking for the greater.
Okay. So it's 0.0097.
Yep.
Yep, that's what I got.
So 0.009. And that sounds right because for once they're asking us to round to the 4th decimal
I know.
point where they normally ask for
I
it.
always use that to determine if I'm doing the answer right because it's always similar to what they put in the parentheses.
Okay, is it my turn?
I think it's Monica's.
So-
I think it's mine.
oh,
Suppose the mean GPA of BYU's Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is less skewed. A random sample of N81 students will be drawn. What is the shape of the sample distribution? Okay, it's approximately normal because it's 81.
Yep.
Yeah, because it's bigger than 30.
Okay. Eileen.
okay. So what is the mean of the distribution of the sample means for all possible samples of 81 that could be drawn from the parent population? Okay, go sit on the potty. So the mean should be the same. Did I lose everybody? Are you also there? Okay. Everyone was being so quiet. I was like, wait a second, did I lose everybody? Where's the mean? So the mean should be the same as the sample mean. So it should just be the 3.5, right?
Yep. That's what I have. Hey, I have a question. If we have a small population, is the sample mean still the same? Is it always the same?
No, you cannot determine if
Is the mean the same in a small population versus a large population?
No, you can't do anything if it's a small population.
because
And
less,
then the data is normally distributed. That was the last questions of I think the homework or the preparation stuff that we did. But essentially, if it's not, if like the data is right skewed and you only have 5 samples, then you can't do any of these
Well, it
equations.
says you
'cause it
can't
won't be
compute
right.
the probability using the applet if it's not normal. And I understand that because it would be skewed. You know, it's not necessarily going to be a normal curve. But can you compute the mean if it's sample size?
I don't. No,
I
I
think
don't think you can.
because the mean is an average, so you can do an average. It doesn't matter, but I don't know if you can work this formula.
I mean, we can still compute the z-score. We just can't stick it into the probability applet. All right, probably not important. Let me talk about question 12. So you guys got 3.5, right?
Sorry, what was the answer?
Is it 3.5 for
3.5
11?
because it's the same mean as the other ones. It's normally distributed.
All right, number 12.
Yeah.
What's the standard deviation of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population? So we're gonna take it. Let's see. Let's go back up. So there's 81.
Just
And our-
sorry.
What is the standard deviation?
Hold on. Standard deviation is that that would just be whatever the standard deviation is, right?
That's what I'm thinking.
So
Sorry,
0.7.
Yes.
Standard deviation should be the same, I think. So you guys got 0.7, or do you think there's something we're supposed to calculate?
I feel like there's something else we're supposed to do.
We have to do, if it's talking about the sample means, we have to take the standard deviation and do the square root of the number given there, that is 81.
Well, that would be the z-score. They're asking around what is the standard deviation of
Yeah,
the
that's what I'm trying to
distribution.
figure out.
No, but that is the formula. I got it. I wrote that. Standard deviation of the distribution of sample means is the standard deviation divided by, that is in the book. Because I get lost, so I wrote that.
You're right. You're right.
Okay.
Yeah, the
It's,
standard
by
deviation
the
of the random
number.
variable is standard
Right,
deviation
right.
divided by the square root of the sample size.
So it should be the 0.7 divided by a square root of 81. So 0.7 divided by 9.
So it's 0.07. Let's see how many do we have to round it to. It says round to 3 decimal 0.078.
0.07. How many do we have to use?
0.08, 3 decimals, or 3 places. 0.078.
Yeah. Just a question, because I got lost in number 11. So it's 3.5?
Yeah, 11 is considered.
Okay, thank you.
Okay, 13. Or is it Monica's turn? I lost track. Whose turn is it?
It's Charity's.
Yeah, okay. What is the probability that the mean GPA for 81 randomly selected BYUI students will be less than 3.3? So do we just put?
So we need to find the z-score, and then we need to put this in the applet.
Okay.
We need to take the 3.3 minus 3.5.
Divided by. Is this the one where we use the sample size? Yeah, it is.
Yeah, so we should do that 0.78 that we just calculated.
Wait, we don't use the standard deviation from. We don't use 0.7. We use.
No, because in this case, because we're trying to find the probability, we need to do that, the standard deviation divided by the square root of the population, which is what we just calculated in that question above.
Yeah, the
81.0.
Then what is the standard deviation from the first?
Oh, I see what you're saying. So now we don't have to do the entire problem because we already have the answer to the bottom part of it.
You got it. It kind of led us into this one.
Okay, so I'm going to try it just the 2 ways.
Yeah, if you want, no, go ahead and put all the hard numbers in there.
But yeah, I got it. Negative 2.56.
4.
But I'm
I got the
going to.
negative 2 points. Believe it or not, guys, this is a question on the homework.
Oh, really?
Yes. This is an exact problem from the homework. But they want to know less or more.
So it's negative.
If I did this,
Are you understanding, Charity, or do we need to walk you through it again?
did you guys get negative 23.076?
Minus.
No, your z-score should be a negative 2.564.
Okay. Yeah.
Okay. So So 0.0052.
And then we get that to the applet, or just that, is
Yes.
that the answer?
So we'll put that in the applet.
Okay. And we have to shade
Just to the left,
to the left, not to the right. Okay, to the left.
because they want less than.
3.3 minus 3.5. You do 3.3 minus 3.5 divided by the point or 0.078.
Correct, that's what we did. And essentially that 0.78 is the same as taking the same randomly selected students that we talked about.
Oh yeah, and the square root of that. Okay, I get it. So negative 2.56.
You got it. And then you got to go put that in the applet.
Okay.
So then the answer is 0.0052?
You got it. But they want us to round to 3 decimal points. So 0.005 should be the answer.
Okay.
Oh, will be less than. So
Yeah, so it's less than.
0.005. Okay.
I have a question. Why? No, it doesn't matter. I think I get. Let me see.
You understand, Monica, how to shade it, where you're shading?
Yeah, I understand that it's less, but I don't know why we don't have to also shade the center, because
So the reason you don't shade the center is because if the answer is a negative, it's negative 2.564.
oh, okay, yeah. So it's
Because
just
it's a negative number, you look at your applet, and if it's below the negative 2 point something, then it's just one section. It's not 2 sections. Let me look at the applet though.
Yeah, so if it had been positive, we would have shaded the middle section and the section to the left.
Yeah.
It would have been a positive 2.5.
Oh, see for the next one. The next one is the same thing. It just says greater.
okay.
So we're just supposed to shine everything to the right of that
Yeah.
negative
So now
2.56.
it's going to be everything to the right. So the middle and the right.
Okay, so the answer is 0.9948.
Yeah.
But in this case, they want 3 decimal points. So yeah, 0.995.
So it's 0.995.
Yes.
Okay.
All right, I think we're on you, Kaylee.
Okay. The United States Coast Guard assumes the mean weight of passengers on commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passengers is 26.7 pounds. The weights of a randomly sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds of just the sample mean of those 48. Find the probability that a random sample of passengers will have a weight that it is as extreme or more extreme than was observed in this sample. And then round your answer.
Okay.
So extreme or more. So 177 or higher is what we're going for. So we'll do our value of 177.6 minus the mean of 185. And then we'll need to divide that by the standard deviation of 26.7 and then divide that by the square root of 48. Is everyone following me?
Yeah.
Yes.
Negative 1. I don't get to plug it in.
So negative 1.9201.
Yeah.
Okay.
So, but it says no. Hold on. What's our question? Our question is find the probability that
So
they
then I have
will
to put down
have it
more.
as extreme or more extreme than was observed.
Okay, so what did you guys get for the z-score?
Negative 1.920.
Just
Yep.
give me a minute. I'm still.
No, you're fine. I was just wanting to see what their z-score was.
Did you guys get that?
Yeah.
Okay.
So how do we know if it's as extreme or more extreme? Oh, either above or below the mean.
So it's the way it's as extreme or more. So essentially it's just more, right?
I don't understand what we're comparing it against.
Find the probability that the random sample of passengers will have a weight that is as extreme or more extreme. So essentially it's from the line, it's really just more extreme because you
So
figure
it's
the
just
z-score is as extreme
anything
and
to
the
the right
more
of the z-score
is
is
going
what
to
we're
be more. Yeah.
Sorry, say that again because I still don't understand. Are we just writing as extreme or more extreme?
No, it
so
says
when you put that
right.
into the z-score, since it says as, you're going to start at the line and do everything to the right because it
We're
says.
putting this into the applet. Is that what we're doing? We're putting it into the applet?
Yeah.
Yeah, you need to put the z-score into the applet and then shade just what is to the right.
What is the c-scores you got?
Okay, so 0.973.
So sorry, Monica, you were asking what the z-score was?
Yes?
So what did everyone get for the z-score? I think we all got it right at the
Negative 1.920.
1.923. Okay, I got that.
And then the answer for the applet is at 0.973.
Yeah, that's what I got.
What are we shading there?
So everything to the right because it says anything as extreme or more extreme. So everything to the right of our z-score, which is negative 1.920.
So it's 0.9726?
Yes. And then you just round it to the third.
Okay.
0.973. Everyone got that?
Yep.
Yep.
Okay. Save all the sentences. I'm going to go ahead and submit the quiz really fast. So we see if that one question back up there at the top that we struggled with was right.
Okay.
It is not correct.
Which
No.
one is not correct?
The one at the very beginning, it is question number 4, where we debated of which of the following will have a similar standard deviation of the 9 observations
I bet
are
it's
randomly drawn.
the actually I don't know.
The middle one? I think it's the middle one that we originally debated, and then we went to the, hey, we don't have enough information because we thought, hey, the values are going to be big. Oh, hang on. Did you guys put 0.973 as your answer on question 15?
Yeah.
You're saying that is not correct.
What? Okay. Oh, freak, if that's not correct.
Then I'm seriously confused because we all got the numbers right.
All right, I'm going to look at 15 for a minute, and then we'll go back to that other one. The United States Coast Guard assumes the mean weight is 185. Okay. The previous value was lower. Standard deviation is that. Okay. The weight of the random sample was recorded. Sample mean was 177.6. So write that down. Minus the 185 all over the standard deviation, which is 26.7.
Divided by the square root of 48.
Yep. Okay. So let's just see what it's asking now. Find the probability. Well, that's what we do. that a random sample of passengers will have a weight that is extreme or more extreme. Oh, you know what extreme or more extreme means? It means we shade the outside two things,
Sure.
isn't it? Because if it's in the center, that's not extreme.
Yeah, I think you're right.
Extreme means the outside.
More.
It says no, as extreme
Okay.
means that we are not only interested in the values that are lower than the ones we observed, but also the values that are far, far away. Oh, so maybe
Maybe
you're right.
below or above.
So the two outside ones, not the middle.
Yeah, that's what's extreme. Anything above 2 is
So
normally
that would
extreme.
be 0.0549.
Yep, so 0.055, 0.055 if it's three places.
0.055.
Okay, so someone else needs to go up and change the question. So put that as 055, and then someone else needs to go up and pick C
Yeah, I'll
or the
submit
middle
it
one.
next. Okay,
Okay.
let me submit it next.
And you pick
0.055, and then the top one, I really don't understand it, but let me just reread it one more time. It's, which of the following will have a smaller standard deviation if 9 observations are randomly drawn? Is it the distribution of the individual observations? And I don't even know what that means. So I'll put the,
Well, normally the distribution of stature means is smaller, so you're going with the middle one, right?
I'm gonna go with the
Okay.
middle one.
I'm
I don't
going.
know.
Okay.
I'll submit. Who's submitting? Because I can do it.
Hey, I'll do it real quick, okay? Let me do it, Monica.
Okay.
And make sure we got it all right, because I'm still worried about 15 too.
Yeah. Okay, it's going through. Let's see. Okay, 2 points, 2 points, 1, 1. It's 100%.
All right, so it is the middle one on question 4, and it is 0.55 on question 15. Way to go, ladies.
So the
All right.
middle one is the sample mean, right?
It is the sample mean, which does make sense, because again, with the sample mean, you have to take that square root of the sample that you're taking, versus if you're just taking one, then you just take the divide by the standard deviation, and that's the standard deviation divided by the square root of the sample mean.
Okay.
It doesn't make sense in my mind. It's just kind of hard to explain sometimes. I hate it when they have us explain stuff. I'm like, I don't know. It just does it. Okay.
Yeah, I don't know what it means by the distribution of individual observations, though. I think
Yeah.
that's just, maybe they're talking about the main population. Who knows?
Mhm.
All right. Well, good meeting. Let me go here. Okay, I'm going to stop the broadcast and
Okay.